All right, let's jump right in. Picture this. A nurse has a new idea. A better way to manage pain, maybe. Or a new teaching method for patients. How do they prove it actually works? I mean, really prove it. That's the huge question we're tackling today.
And this is such a fundamental question for all of healthcare, right? It's just not good enough to think something works. You have to prove it. You have to be able to separate what's a real effect from what's just, a happy coincidence. This is all about finding that elusive cause and effect. And trust me, it's a lot trickier than it sounds.
So, to get the absolute strongest, most rock-solid proof, researchers have a go-to method. It's known as the gold standard for a reason, the true experimental design. This is the one that lets us say with the most confidence that, yes, this intervention is really what's causing the change we're seeing.
And hey, this isn't just my opinion. The research literature is super clear on this. This design is, hands down, the most powerful tool we've got for figuring out causality. When you absolutely positively need to say A causes B, this is the design you reach for. It's all about control.
So what's the magic formula here? What makes this gold standard so special? Well, it all boils down to 3 essential, non-negotiable ingredients. If a study is missing even one of these, then sorry, it's not a true experiment. Let's break them down.
First up is manipulation. Now, this sounds a little intense, but all it means is that the researcher doesn't just sit on the sidelines and watch. No, they actively do something. They introduce a change, that new treatment or protocol, to see what happens. They're literally manipulating a variable to check out its effect.
Yeah, a perfect, super simple example would be, say, a study on anxiety. A researcher might give one group a specific herbal tea, while another group doesn't get it. That act of giving the tea, that's the manipulation. That's the intervention they're testing.
Okay, next up is control. And this is absolutely crucial. I mean, how do you really know the herbal tea worked? Maybe those patients' anxiety would have gone down anyway. To figure that out, you need a control group. This is a very similar group of people who don't get the tea. They give you a baseline, a point of comparison, so you can see the real effect of your treatment.
And finally, we get to the most critical piece of the puzzle, the one thing that truly makes an experiment the gold standard. And that's randomization. This, right here, is the secret sauce. It just means every single participant has an equal shot of being in either group, the one getting the tea or the one not getting it. It's like flipping a coin. By leaving it to pure chance, researchers can be pretty darn sure that the only real difference between the two groups is the intervention itself. And that's what lets them nail down cause and effect with so much certainty. Now this is so important because it clears up something people mix up all the time. See, random sampling is about how you pick people from the big, wider population to be in your study. But random assignment, that's randomization, is how you then divide those people into your groups. It's that second step, the assignment part, that is the absolute 100% must-have for a true experiment.
So, okay, the true experimental design. It's powerful, it's elegant, it's the ideal. But, as we all know, a busy, chaotic, unpredictable hospital ward is about as far from a controlled laboratory as you can get. And this is where the real world comes crashing in.
Which brings us to a really obvious question, doesn't it? If this design is so perfect for proving things, why isn't every single nursing study a true experiment? Well, the answer comes down to the very real, messy, practical, and ethical challenges of taking care of people.
I mean, just think about it for a second. Is it really ethical to withhold a treatment that could help someone just for the sake of a study? A lot of the time, the answer is a hard no. Or can you imagine trying to randomly tell patients, sorry, you're going to Ward A while others go to Ward B? It's just not practical. Plus, you're dealing with complex human beings, not chemicals in a beaker. You throw in hospital politics and tight budgets, and that gold standard can suddenly feel completely out of reach. But here's the thing. Researchers are clever. When the gold standard just isn't an option, they've got this incredibly powerful and practical alternative. It lets them gather really strong evidence, but right there in the real world. And it's called the Quasi-Experimental Design.
And the name itself is the perfect clue. Quasi comes from Latin, and it means resembling or almost. So a quasi-experimental design is, you guessed it, an almost experiment. It's designed to get as close to that gold standard as reality will let it.
So what's the big difference? What makes it almost instead of the real deal? Well, the missing ingredient is almost always that superstar third element we talked about, randomization.
There's no random assignment of people to groups. That's the key.
So in a quasi-experimental study, you still have manipulation. The researcher's still introducing some kind of new thing. But because there's no randomization, the groups you're comparing are often already formed or intact. A classic example is comparing a new protocol on ward A with the old one on ward B. This means your control group isn't a perfect randomized match, so we call it non-equivalent. The result? Our confidence that the intervention caused the outcome is still pretty good, but it's what we call moderate instead of the very high confidence we get from a true experiment.
And this diagram here shows a super common way this is done. Let's just walk through it real quick. You've got two groups, experimental E and control C. First, the researchers measure both groups to get a starting point. That's O1, the pretest. Then, the new intervention, that X, is given only to the experimental group. And finally, they measure both groups again, that's O2, the post-test. By comparing the amount of change between O1 and O2 in both groups, they can get a really good idea of the intervention's effect, even without that initial coin flip randomization.
All right, let's do a little showdown. Let's put these two designs head to head, because seeing them side by side really makes the core differences pop, and you can really get a feel for when and why you'd use each one.
So on one side, you've got the true experimental design. This is your gold standard. It gives you maximum control and therefore super high confidence in cause and effect. And on the other side, you have the quasi-experimental design. This is your practical, real-world workhorse. You have less control, but you still get valuable evidence with moderate confidence.
This table just lays it all out perfectly, doesn't it? Look, both designs have manipulation. That's a yes for both. Both often have a control group. But then you get to that randomization row. See that? It's mandatory for a true experiment, and it's what's specifically missing from a quasi-experiment. That single difference is what leads directly to that last row, the level of confidence we can have that our intervention is what truly caused the outcome.
And you know, this is exactly why nursing research relies so heavily on these quasi-experimental studies. In fact, you'll see more of them in nursing than you will true experiments. They just strike that perfect vital balance between being scientifically rigorous and dealing with the practical, ethical, and financial messiness of healthcare. They let us find real evidence to improve patient care right here in the real world.
And that really brings us to a final, interesting thought. As medicine and patient care get more and more complex, more personalized, what new research challenges are going to pop up? And what kind of even more creative, clever study designs are we going to need to invent to keep pushing evidence-based practice into the future? It's a pretty cool question to think about, right?